In this video, we're going to discuss the vertex of a parabola and how it relates to word problems with projectiles being launched. On the graph that I drew on the page here is the path of a projectile that was launched at time t is equal to 0 that landed at time t is equal to 4. And we might be asked what this vertex represents in the context of the problem. If you imagine some projectile being thrown, starting over here and being thrown from here until it reaches over here, then it starts going downwards. The maximum point over here obviously represents the maximum height of the object. Something else you might be asked is, what time does this maximum height occur? And for this graph, it would be at time t is equal to 2. Or you might be asked, what is the maximum height of the projectile? And that would be 6 feet for this problem. That's how you figure out if you have a graph. You just look at the graph. Let's say you have an equation, not a graph. Let's look at a Regent question from the January 2016 Regent, question number 33. This question actually has two parts. We're only going to do the first part because that's related to the vertex, which is what we're discussing. Let h of t equal negative 16t squared plus 64t plus 80 represent the height of an object above the ground after t seconds. Determine the number of seconds it takes to achieve its maximum height and justify your answer. What we're looking for is, let's say the graph of this, say this graph looks something like this, and the x-axis represents time, the y-axis represents height. We're looking for at what time does this maximum value occur. Whenever we're finding the maximum, when we have an equation and we're finding the maximum or the minimum of vertex, we're solving the equation x is equal to negative b over 2a. And in this case, we're doing t is equal to negative b over 2a because our x-axis represents time. So let's plug in the values from our equation. T is equal to negative b, in this case is 64, over 2 times a, which in this case is negative 16. Negative 64 is negative 64, over 2 times negative 16 is negative 32. Negative 64 divided by negative 32 is positive 2. So t is equal to 2 seconds. The object will reach its maximum height. And justify your answer just by showing this work, t is equal to negative b over 2a. And the question doesn't ask this, but let's say we wanted to find what actually is the maximum height. We would plug in the t is equal to 2 into the original equation to solve for h of 2. Let's do that. So we have h of 2. We just solved that the maximum height occurs at t is equal to 2. So h of 2 is equal to negative 16 times 2 squared plus 64 times 2 plus 80. And let's solve for h of 2. H of 2 is equal to negative 16 times 2 squared, which is 4, plus 64 times 2 is 128, plus 80. And then h of 2 is equal to, let's just plug the whole thing into the calculator. Negative 16 times 4 plus 128, plus 128 plus 80. That's h of 2 is 144. So the maximum height of this object would be 144. It doesn't tell us the units, so just 144 units.